Okay, welcome everybody. Welcome to this Blockchangers event. How many here has been to a Blockchangers event before? I see some familiar faces. About half. So this is a group that's been here about 2 years. We have monthly meetups. We organize the yearly annual Oslo Blockchain Day. And we have different aspects on the format. So we have technical stuff for developers, workshops and so on, and we have more business developer strategy things as well. Today the SegWit was implemented into Bitcoin. Congratulations everybody. So that means that we're out of the rut with Bitcoin. So there's something actually happening. And one of the things that SegWit makes possible is the Lightning Network, which I guess a lot of us don't really know what it means. So we have Johan here from Lightning Labs, who's going to tell us everything about it. Thanks.
Okay, thanks. Can you hear me? Yeah. Okay. I was going to do this in Norwegian, but then I realized maybe not everybody here understands English. So I'm going to do it in English as well. Okay, so welcome. As John said, I'm Johan. I'm currently working at Lightning Labs, which is one of the startups or companies trying to implement this thing called the Lightning Network on top of Bitcoin. I'm based in Trondheim, but I work remotely with the San Francisco team, so that's fun. And I'm going to give you an introduction to what the Lightning Network is, because I guess if you've been in Bitcoin for a while, you probably heard about this Lightning Network that's gonna solve everything, right? But even if you don't know totally or understand it completely, hopefully after my talk you're gonna have a rough understanding of how it works and what problems it can solve. So, okay, so what is the Lightning Network? So the Lightning Network is kind of like a proposed payment layer on top of the Bitcoin blockchain. This is sometimes called a layer 2 solution. This means that it uses the Bitcoin blockchain as a base layer, and then on top of this layer, you have a network of nodes that can communicate and do instant payment to each other without touching the Bitcoin blockchain that much. This gives us some interesting characteristics. First, as mentioned, you get instant payments. I'm going to get back to this, but in Bitcoin, one payment is usually quite slow, and they're also quite expensive. So in Lightning, we are pretty sure the payments are going to be quite fast and quite cheap. And a second thing is that it enables a very high throughput of transactions. So it's probably going to scale to millions, if not more, transactions per second, there's really no limits to why it can scale even further, and I'm going to tell you why that is. It's hard to understand Lightning without having some blockchain basics. So I assume most of you know kind of how a blockchain like Bitcoin works, but I'm going to go through the necessary basics so what you need to understand why Lightning works and what problems it can solve. So a blockchain is basically a very slow database where you can That's not going to happen. Yeah, it's a very slow database where you can append data, but you cannot really remove data from it. In Bitcoin, about every 10 minutes, a new block is added to this chain of blocks, hence the name blockchain. And each block like this encodes the transactions that have happened since the previous block. And this is amazing. Nobody thought it was going to work, but it has been running for several years, and it works pretty well, actually. but it has a few limitations. First, it's quite slow. As mentioned in Bitcoin, about every 10 minutes you get a new block. So if you do a payment, you would assume it will take at least 10 minutes for your transaction to confirm on the Bitcoin network. Often you will wait even longer because you want it to have a few numbers of confirmations to be sure the transaction is not reversible. Second, it's expensive. Because the space in each block is limited to a set number or fixed size of transactions, there's a fee auction for every block where people are bidding on the transaction fees to get into the block. That means that if you pay a higher fee, you're more likely to get into a block. And since Bitcoin has become quite popular right now, the fees are quite high, and that's a problem. And because of this, or because of a lot of factors, the Bitcoin blockchain do not scale, or blockchains in general do not scale very well. And this is kind of like a result of the design with blockchains, that every time you create a transaction or want to send a payment, you have to tell everybody in the network. So even with big blocks, you risk that you have to flood the network with gigabytes of information every 10 minutes to be able to do every payments that everybody in the world wants to do. And imagine if this was the case for internet traffic, that every time you logged onto your smartphone to check the web, you had to download the data for every user on the internet in the whole world. It does not scale very well. So with Lightning, we try to do something different. We try to do something called off-chain payments, which is a totally new way of doing transactions. I'm gonna tell you what that means. But basically, it means that instead of flooding the network with your transaction and telling everybody about it, only the involved parties in the actual payment know about this transaction. Okay, so how do we make Lightning work? Bitcoin has a nifty feature called Bitcoin scripts, and this lets you create kind of like a smart money kind of system with Bitcoin. This is sometimes called smart contracts as well in Bitcoin, and they're kind of like small programs that are tied to each coin, and you have to make this program validate to be able to spend that particular coin. So we can look at this example here. This is not technically correct, but you get an idea. So if a coin has a script like this, it means that it can only be spent 30 days after it was mined, and it can only be spent by somebody that knows Val's key, and that's presumably Val, if he knows his key. And with scripts like this, obviously more complex scripts than this one, we can create a smart contract system that powers Lightning. So a Lightning network is more or less like other peer-to-peer systems. You have a node, and you connect to other nodes on the network, and then as long as there's a path in this network, you can send messages, and in this case, payments to the other participants in the network. If A, in this case, wants to pay B, she only needs to find a path through this network. And I have a meeting. Yeah, so Alice will have to find a path through this network to D, and in this case, that might work because there's a path. But in Lightning, in contrast to other peer-to-peer systems, we don't really talk about connections in this case, but we talk about payment channels between the peers in the network. So as long as there's a route of open payment channels in this network to the peer you want to pay, then you can do the payment. So what is a payment channel? A payment channel, or payment channels in general has been known, and they have been in use in Bitcoin for many years actually. It was just that early designs of payment channels were quite limited in what they could do. In the early designs, Alice could open a channel to B if she knew she was going to pay B a lot. And then she could do a lot of payments and then close the channel when she was done. What the Lightning white paper introduced when it was released was something called bidirectional payment channels, meaning that Alice and Bob can open a channel and then they can do payments between each other. Not only in one direction, but Alice can pay Bob and Bob can pay Alice in both directions. And this channel can be open for as long as they want. As long as they want to do payments, they can keep this channel open and they don't have to close it. So a payment channel is basically just a signed Bitcoin transaction that both of them hold with a balance. In this case, Alice has a balance of 10 Bitcoin and Bob has a balance of 5 Bitcoin. So instead of, if Alice wants to pay Bob 2 Bitcoin, she could create a normal Bitcoin transaction with 2 Bitcoin, send it to the whole network, and they would know about it, and Bob would get the 2 Bitcoins. But in a payment channel, instead of doing this, you just update the balance on the transaction you share. So nobody else needs to know about it. These peers are the only two that knows about this specific transaction. They update the balance and it's done. The payment is done. Okay, let's go a bit more into the details of such a payment channel. If Alice and Bob decides they want to open a payment channel, what they would do is they create what is called a funding transaction. This funding transaction is a transaction where both put the money into. In this case, Alice puts 10 Bitcoin in it and Bob puts 5. And this funding transaction is mined. It's broadcast to the Bitcoin network and it's put on the blockchain. The funding transaction is immediately followed with what is called a commitment transaction, and this is where the magic happens. The commitment transaction is a normal Bitcoin transaction as well that gives the money back to the original owners, but they have some special outputs. These outputs are what is called time locked, meaning that if this transaction is mined, the owners of those outputs cannot spend those money immediately. This is exactly what I showed you in this script, by having the script telling you that this transaction this output cannot be spent for 30 days, say. So in this case, both have the commitment transaction. They can broadcast it to the network and get their money back after that time has passed. But why would they open a channel if they just want to broadcast this commitment transaction right away? What they do want to do is they want to start paying each other. And they do this by updating the commitment transaction. If Alice pays Bob 2 Bitcoin, they would update the balance, or maybe she is paying 1 Satoshi every second or something for as long as they want. And they can keep on updating the balance of this transaction for years or for millions of transactions, whatever, how many they want. After a while, they might decide they want to close the channel. They do this by they agree on the final balance of the channel. They create a closing transaction and broadcast the closing transaction. The closing transaction it's kind of similar to the commitment transaction, only that the funds are not time locked, so they can spend the money right away. And this is basically what is needed to create a payment channel. So on the blockchain, only the funding transaction and the closing transaction is ever put. So they can do millions, billions of payments, but only 2 transactions are broadcasted to the network. But then peers can try to cheat you, right? So what Alice could do in this case, after she has sent the money to Bob, she could try to broadcast the previous commitment transaction to the network. Yeah.
Just one question. Where are the funds held after the funding transaction? So are they in a new account or?
So they're held by the funding transaction. The funding transaction is a transaction that is controlled by Alice and Bob. So to spend the funds in the funding transaction, they have to agree, they both have to sign the transaction that spends those funds. Meaning that if one of them refuses to sign, they cannot move the money. And this is where the new activation of SegWit comes in actually, because before you broadcast the funding transaction, you create the commitment transaction. And they both sign the commitment transaction, moving the money from the funding transaction into the commitment transaction, so they know that when the funding transaction is moved, both of them have this transaction, so they can broadcast it to get the money back. Before SegWit, this was not possible, because you could broadcast the funding transaction, but because of a bug called transaction malleability, they could change the signature or the ID of the funding transaction, meaning that this one would point to some transaction that didn't exist. But because of when we fix the transaction malleability, we know the ID of the funding transaction, and we can point to it even before it's mined. Meaning that after these two are signed, we can safely broadcast the funding transaction, because both Alice and Bob knows that in the worst case, they have the commitment transaction and they can get their money back. Okay? So yeah, so let's say Alice wants to trick Bob. She sees that in this situation she has 8 Bitcoin, and in this one she has 10. And obviously 10 is better than 8, so why don't we just broadcast this one and get 10 Bitcoin back? We have, this is where we have something called a revocation clause. So every commitment transaction has a revocation clause that says, so for commitment transaction number N, it has a clause saying that if Bob can present a commitment transaction that has a higher number than N, then he gets all the money. Meaning that if Alice tries to broadcast this one, Bob would see that and say, but I got this transaction, and I can show that to this clause in the previous commitment transaction that I know a newer commitment transaction, meaning Alice tried to cheat me, and he can take all the money. So this means that none of them are incentivized to cheat, because if you do that, you will lose all your money. So you should play by the rules. Okay, more questions on simple payment channels? Yes?
Sorry, it's not simple payment. I guess.
Just
go. So, do you really have any incentives if you used all your bitcoins? You would kind of be incentivized to try and cheat if you spent all your bitcoins that you've committed.
Yes, that's a good point. So let's say Alice pays everything to Bob, so she now has 0. Then she has, even though she tries to broadcast old one, she doesn't lose anything, right? Because she has 0. So actually, this Lightning spec and also the implementations don't allow that to happen. So both parties always need to have some money in their balance. So if the balance go to there's some threshold there. So if you try to go below that, you won't forward channels over those. Bob would refuse to take more money from Alice, basically. Okay, so let's look at how this,
all the transactions in the payment channel then, are they broadcast to the main Bitcoin blockchain, or?
No, only the first one and the last one.
Okay.
So this is kind of the starting balance, and this is the final balance. Basically.
So does that erase any auditability in any way?
Yes.
Yeah.
Luckily it does. Yeah, so you have no idea how many times they pay each other. Only they know. Okay, so how does this payment channels create what we call the Lightning Network? So the Lightning Network is basically a mesh or a network of these payment channels between nodes. So if you're part of this network and the node you want to pay is also part of this network, you can find a path and pay that node. For example, let's say Alice or A wants to pay E in this example. She would look at the graph, she would find a a route in this graph of open payment channels, and she would send a payment along that route. The way this works is it's quite simple actually. A pays B, B pays C, C pays D, and D pays E. And in effect, this is the same as A paying E. So that's kind of the easy way of explaining this. But of course, there might be someone who tries to trick you around this. So let's say C here is malicious. He's a bad actor. He wants to get paid by B, but he will never forward the payment to D. He will just take the money himself. How can we make sure this doesn't happen? And this is solved by something we call a payment contract. A payment contract works a bit simplified like this. C will only pay D if D can prove that he paid E. And the same way, B will pay C if and only if C pays D. And A will pay B if and only if B pays C. This means that either the payment goes through from A to E because this payment has to start and then all of them will happen, or none of the payments will go through and it's basically like the payment fails because somebody was acting malicious, but at least nobody lost their money. This means that we don't have to trust any of the intermediaries on the route, so you don't have to know anything about how they behave because your money is safe always, anyway. And because of this network, we can get some very exciting new applications that have not been possible before with regular Bitcoin payments. The two obvious ones that I probably mentioned several times already. It's very cheap payments. So I didn't mention that. Yes. So along the route, they can charge a fee for routing transactions in the graph. But as long as so when Alice decides she wants to send a payment to E, she can choose the route. So she will ask all of them for the fee before she sends the payment. So if somebody tries to charge a very high fee for sending payments, they will just be ignored. As long as there is a cheap path in the graph, Alice would choose that one. So yeah, you can actually earn Bitcoin by charging fees. Yes, also micropayments. Yeah, I didn't mention. So this is something that I would say hasn't been possible before to do micropayment transactions, like really small transactions, on the order of maybe cents. You can do fast payments to different nodes in the graph, very small. Actually, the Lightning spec allows you to do transactions less than 1 Satoshi. So you can do milli-Satoshi payments in the network, which is, I don't know how much that is, but it's probably enough. Also, as we mentioned earlier, a less known benefit of a Lightning network is better privacy. So the routing in the graph uses something called onion routing, which is known from the Torås project. Basically, that means that during such a payment, C only knows that the payment is going to D and is coming from B. He has no way of telling who originally sent the payment and what node is going to. For all he knows, B is paying D, and D is the target. He has no way of telling. He only knows the previous and the next node on the path. So this leads to better privacy, and also because only the funding transaction and the closing transaction is broadcasted to the network, it's much harder to track payments on the public Bitcoin blockchain.
Won't C know that that Alice queried about the transaction piece? So the payment is actually coming from A?
No, not really, because the way you announce your transaction fee is by just like a regular Bitcoin transaction. You flood it to the whole network. You can create a message saying this is my channel, this is how much I will charge you to send payments on this channel, and then you tell the whole network of assets. Yeah. So this is all fine in theory. What's the current status of the Lightning Network? As you might have guessed, it's not active just yet on the main Bitcoin blockchain, but it has been running on Bitcoin testnet for a while, and it works pretty well. There are bugs, of course, but after a while, it will be good enough to deploy to the main network. There are something called the bolts, which makes up the Lightning specification, which is a set of documents that in detail goes through how the protocol is working. So you can have multiple implementations of Lightning clients that follow this protocol. And currently there are 3 implementations that are adhering to this protocol. It's Eclair, which is a Scala implementation by a French team called Async. There's C-Lightning, which is a C client by Blockstream. And then it's LND, which is by Lightning Labs, and I'm going to tell you more about it.
Do you have to be a Bitcoin node to run this in top?
Sorry?
You have to be a node, a Bitcoin node, connected to the Bitcoin.
Oh, yeah. I'll go into that here, actually.
Okay.
So our implementation, LND or Lightning Network Daemon, you will need to have a full node or a light client. A light client is basically if you have control your own private keys on your cell phone, you're running a light client. So this is similar. This can also be done on Lightning. So yeah, Lightning Network Daemon is the implementation by us at Lightning Labs. It's written entirely in Go, which makes it very portable. It can run on most operating systems, I would say, and it's portable because of that and because of the light client we announced, which you should look up it's a very cool light client actually. And it's all open source, and we try to be very developer friendly. So we try really, really hard to make it easy to use for developers or products. So you can just hook it into your app and start sending payments and receiving Bitcoin like very easily. But of course, there's more work to do in that area. If that sounds tempting, you can go to our blog or our developer documentation, which gets updated when we are not lazy. There you can also find a link, an invitation to the Slack, which is that's maybe even more useful because you can always ask a question on the Slack and you will get updated information. So join the Slack or look at the code, contribute to the code. I think this screenshot is from yesterday. We have 33 contributors so far. There's room for more. Or you can take a look at the specifications if you want that. So that was my talk. I have a small demo, but we can also do questions if you want.
Go.
Okay. Let's do the demo first. We had a release yesterday actually, so.
I have a question about this trust channel.
Okay, yeah, let's do it first.
Each one you don't need to trust because of the end payment needs to happen before the first one.
Yes.
So what if A and B agree that B will make payment, then B will make payment to E,
Okay.
but A will never pay A. And then because of they cooperate. And
So they cooperate.
yeah,
D
they
pays E.
yeah, but A will never pay D.
Then B loses his money. Right?
Yeah, but the goal of A and E together is to earn money
Yeah, but-
together.
Yeah, but that money would have gone to B anyway, right?
Okay, let's have 3 nodes.
Okay.
A, B, and C.
Yeah.
Okay, if A wants to give money to C,
Yeah.
then first B gives money to C,
Yeah.
and that's it.
Yeah.
A is not going to give money to B.
So B lost money.
Yeah.
Yeah, but they were cooperating, right?
No, A and C are
Oh, A
cooperating.
and no, that can happen because the moment B pays C, he has a proof that he can show to A that gives the money to B. So if if B shows Alice his proof, but Alice refuses to give him the money, he can just close the channel and show this proof to blockchain, and he can take all the money.
Okay.
Okay.
So everybody's kind of part of the smart contract on the.
Yeah, either it happens and there's like one secret in this contract that is held by E, and the moment he releases this secret, everybody can claim their payment. Yeah.
Do you have to do multiple transactions within a payment contract? Because otherwise it just seems like one transaction results in two blocks.
If you only want to do one transaction and then close your channel,
Yeah.
there's no point in opening a channel. You should just do a regular transaction.
So what type of parties would typically use this mechanism? So is
I have no idea. Hopefully everybody will, right? Because if I promise you cheap payments, instant payments, and maybe even earn you some fees by writing payments, then why wouldn't you? I think you first.
Wouldn't you be limited to paying a maximum amount of the minimum payment channel open?
Yes, that's a good point. So it's limited. So if you find a route in the graph, the maximum payment you can do is the smallest channel on that route in the graph. So by design, actually, the spec, I think the spec caps the payments at like 0.16 Bitcoin or something. So when the spec was created, that was like $40. It's like $600 now. And the reason they do this is because this is still early software, and when we release it, we don't want people to open like huge channels and then some bug is introduced and they lose the money. So when it gets released, it's only going to be for very small payments to begin with. But $600 is still, it's not that bad. Yeah.
Is there like a maximum length? Can you lock away for 100 years? Like, can you open a channel which will last you for 100 years?
Yeah. There's no maximum length on the channel. Everything is, there's no.
And you mentioned like small amounts, but what methods are you using in order to prevent someone from like a bug triggering you locking away your funds forever,
Of course, you cannot prevent a bug from deleting your private key or something, but that's the same for normal Bitcoin wallets, right? There can be a bug in your Bitcoin wallet that deletes your database or something, and you lose your access to your money. That can happen here as well, but hopefully we're trying to create software that, by intention, it tries to keep your private keys safe. Okay.
Yeah. Can I combine multiple routes in one single atomic payment?
You probably can, but the spec doesn't allow that currently.
Okay.
We're trying to keep the spec for the first version very simple to make sure this works.
How do you decide the cheapest route in the network?
So every time when somebody opens a channel, they broadcast this to the network, so you know about the channels, and then you can just look at your local graph. Right now you actually know about the whole graph all the time, so you can just do a local search in that graph and find the cheapest route. And if something happened with a route and you didn't get the update, you will do the payment and it will fail and you can try it.
Okay. So
you'll get actually when you send the payment and there's something, maybe one channel is depleted, so you cannot use that channel anymore. You'll get an error back saying that this is a new update for a channel, and you will update your graph.
wouldn't that incentivize me to just close my channel every time I have a transaction to have the network up to speed on my balance? So
you don't have to.
I would get more throughput through my channel.
But you can send channel updates after a payment. You can update.
Okay.
You can tell the network that I have an update to my channel. Please support. Okay.
Yeah, I'm just trying to build some intuition here. It strikes me that perhaps you could compare this to if you had a sort of movie Dumb and Dumber, where
Yeah,
they have where they find all this money and then they go spend it, and every time they spend it, they write an IOU and put it in there. Maybe this whole box of money is the funding transaction,
Yeah.
and then you write IOUs,
Yes,
and
exactly.
then in the end, everybody actually get the money.
Exactly. So
As
you
opposed
always
to
have this.
really-
Yeah. Each channel is this IOU,
Yeah.
and everybody keeps track. And but the thing is that they're created in such a way that if somebody is trying to cheat, I can always get the money back.
Yeah, so just want to pick you a bit more on who would use this. So I'm just trying to grasp how this could play out.
Yeah.
So say I go to some remote place where I've never been before and won't go again,
Yeah.
and I want to buy coffee with Bitcoin.
Yeah.
Would it be right to think that then maybe that coffee store accepting Bitcoin would
Yeah.
use some intermediary node which runs the Lightning Network or whatever and keeps these fast bookkeeping up to date?
Yeah.
So when I go there, I use this node, I send my payment through that node to the coffee store, and then
Yeah. So
they
this,
get the money instantly, but I don't have to be part of the,
oh,
or
but
they,
why don't you want to be part of the network?
that seems like,
We want you in the network.
hmm?
We want you to be a part of the
Of
network.
course. that's like people running actual Bitcoin nodes, like they don't do that. That's just not the way, like mass adoption people don't do the techie stuff. They just want it to be simple and
Yeah.
so.
So you want to pay them, but you don't want to be part of the Lightning Network.
Yeah,
That's what
maybe
you're saying.
I will. I'm just wondering like who would facilitate this, because to me it seems like okay, so you're taking off the main blockchain of Bitcoin.
Yeah.
So you instead trust some other party to keep some ledger up to date
Okay. So
before they sync to the
okay. So
main.
probably what's going to happen is that maybe you use Coinbase, and Coinbase are very much incentivized to be part of the Lightning Network. So you keep your money at Coinbase, and you just send the payment, and Coinbase handles it like Lightning transaction for you to the coffee shop if they're part of the.
Except Coinbase don't actually hold your money anymore. You hold your money, you just have a Lightning channel that Coinbase, right?
No, I was thinking that Coinbase is actually holding your money, if that's what you want. If you want to hold your money yourself and send a Bitcoin Lightning payment, then you have to be a part of it. It's very hard to get around that. Okay.
Can you say something about how basically Litecoin and Bitcoin are activated? Can you say something about how they would basically build the bridges between them, because that's one of the sort of
Oh yeah, that's interesting. That's something they call atomic swaps.
right.
So basically what that's, as I was saying, when you do a payment like this, he releases a secret that makes all these payments happen. You can also use this secret for this exact same thing. You can say, I have a Bitcoin transaction, I have a Litecoin transaction, both are guarded by the same secret. So the moment you release that secret, both of those transactions go through. So either none of them goes through, or both of them, which means you can do like atomic swaps between
Right.
Litecoin.
And does that mean that both A and E or whoever basically needs to run both full nodes or lightweight?
Yeah, both have to run a Lightning client that supports Litecoin and Bitcoin.
Right.
Or I think this one, or client supports Litecoin. So it doesn't support atomic swaps at the moment, but it supports running on both chains.
Right. So this probably would make it a faster and cheaper way to exchange one for the other.
Yes,
So you, yeah, right.
but it's still like this is still kind of like a science project, right? Because you need to have like a distributed order book or something,
Yeah.
and this can probably be solved, but it's not part of the first version of the spec. But I think it's gonna be fun when we get there. Okay.
You talked about anonymity, that nobody would know who got the money, but to set up the route, you have to say, I want to speak with E. Can
Yeah.
you find a way towards E?
Yeah.
So everybody on the network would know that something is setting up a channel.
Yeah, you would know that A has a channel with B,
No, but to get from A to E, you have to broadcast. I want to speak with E. Do you know? E?
No, you don't broadcast that.
Now, how do you end up with E?
I can go talk to you. If I'm A, you're E, we can talk here, like in real life, and we exchange the necessary information and we do the payment.
Yeah, but you have to find the route. You have to find B, C, and D, which connects us. And
Yes, but that's public. That's you know about the graph, so you know that E exists in the graph, so you know how to find. As long as you give me your address, I can find a route to you because I can see you in the graph. I can see that address in the graph.
okay, so you do have a public graph then.
It's a public graph, yeah.
Okay.
But you can actually do I think, yeah, this is something I'm working on right now, so it's not implemented yet. But what you can actually do is, let's say this guy, let's move to this guy, he has a channel here, but he never broadcasts his channel. It's not a public channel. So what he does is that the only two nodes that know about this channel are those two nodes. It never broadcasts this channel to the graph. And then when I tell you, this one tells A to send me a payment, I will tell A, just send the payment to this guy, and then you add this extra little secret at the end, and this guy will know what to do about it. Basically. So he will send a payment, he has no idea where you are, he only knows that as long as I send it to this guy, he will find the route to my node. So this can be like a use case for like edge nodes that only wants to receive or send payments. They don't want to be a part of the routing. They don't want to earn fees by routing. They just want to receive and send, and they don't want anybody to know about their channel. Yeah.
I heard about mass withdrawal attacks.
Sorry.
Mass withdrawal attacks. Is that for this, or is that?
Yes, it also applies to this.
Yeah.
What that means basically is that I said something here about the time locks. So if Alice tries to broadcast on all commitment transactions, and after this time lock, giving B some time to show this proof, basically. So it gives B some time to claim the money that Alice were trying to steal.
But Alice can spam the blockchain.
Yeah. So with a mass withdrawal attack, if everybody closes the channel or everybody is spamming the network with very high transactions, very high fee transactions, you risk that before I get to provide this proof, the time has passed because I can't get my proof into the blockchain because it's too full and people are paying very, very high fees.
And so essentially the cost is of performing that attack is the length of time plus the amount of blocks and the amount of transactions in those blocks.
Yeah, exactly. So that's one reason we want to keep channels quite small to begin with, so people are not incentivized to do this. And also if B tries to steal A tries to steal those 2 Bitcoin, it should cost her less than 2 Bitcoin to spam the network and to trick B, right? So if this happens, B has some time to try to get this transaction into the blockchain, and since you can make the commitment transactions replaced by fee, Bob can try to pump the fee as high as he can, as long as he's incentivized to try to get this into blockchain. And you basically can pump the fee up to 8 Bitcoin here because he will earn money up to 8 Bitcoin.
How do you know how much the fee should be for closing transactions if it's 30 or 60 days down the line? Is that negotiated between A and B, or?
Yeah, so the closing transaction is broadcast right after it's created, so it's not a problem for that one, you know it. But for this, you don't know, right? Because maybe when we started this channel, it was very cheap, so we didn't have to put a very high fee. But this channel might go on for like 2 years, and the fee has been gone up very, very quickly. So we have just a message between them saying that I want to update the fee, I want to bump or decrease the fee, and if they don't agree, they close the channel. If they agree, they increase the fee and keep on going. So it's up to both of them to monitor the fees on the blockchain and make sure the fees on the last commitment transactions are high enough.
And the closing transaction is already sort of part of the blockchain node.
The closing transaction only happens when they want to close the channel. They create it and broadcast it right away. So they can take a look at the fees, create the transaction and broadcast it. So it's just like a regular transaction.
Are there any big design differences between the Lightning Network and Raiden?
And Raiden?
Raiden, sorry.
I don't know Raiden that much. So I think it's similar, but one is on Bitcoin and the other one is on this scammy blockchain called Ethereum. No, I don't know. I don't know Raiden that much. I think it's probably the design is a bit simpler because you have more features in Ethereum, but I think the principle is similar.
So both parties have to agree that you want to close the channel, right?
Yeah.
So if one of the parties never want to agree to that, then the funds will be locked in there forever.
No, if A wants to close the channel, but B, for some reason, he does not want to close the channel, A can just broadcast this as a commitment transaction and wait the necessary time and get the money. So
And then everything will be reversed back to the...
No, this is the last state. So basically, the only difference between this one and the closed transaction is that in the closed transaction you get the money immediately, while in this one you have to wait for the money. Or it's actually a bit more complex than this. So if B refuses to close the channel, A has a commitment transaction that only locks the funds for B and not for herself. So actually, B is the only one that has to wait for her to get this money if A closes the channel without B cooperating.
So both can actually close the channel at any given time?
Yeah. So for example, let's say they have a channel open. A really needs her money for something else. She needs to take it out of the channel. But B is offline maybe. The node is shut down. The channel is still open, but you cannot communicate with it. Then you can do this force close, as you call it. You just broadcast the last commitment transaction, and you get your money back.
So that means you can literally force somebody else to not have access to their money for the time that you agreed on.
Yes, I think you are correct. Yes.
Okay.
There will be a cost.
No, not for you, just for the other guy.
Let's see.
Because you
okay.
transmit the last known commitment transaction, you get your money immediately, and the other guy gets his money time locked.
Let's see. No, I didn't think about it. So you broadcast your commitment transaction, and since you broadcasted that one, I said the wrong thing. So the one broadcasting the commitment transaction is the one that gets the time lock funds.
So you won't get your money immediately.
No,
Anyway.
you won't. And this
So
is
your
because,
example was wrong.
yeah, that was wrong. It's the other way around, of course. Because if I broadcast an old one, Bob or A broadcast an old one, he needs the time on this end to steal the money. So if you broadcast an old one, you're the one that has to wait. So that was my bad.
How long is that time lock?
It's configurable. So when you open a channel, you negotiate what you want the time lock to be. I don't remember the default value for that.
So while you have the transaction open or the payment channel, the information is only stored at these two nodes, right?
Yeah.
So how is that information secure? How is that ensured that
It's up to the nodes to ensure it.
It's the same way that you secure your Bitcoin wallet.
Yeah, have the information, they can do whatever they want with it. They can lose it, they can do whatever. It's up to them to keep it secret. So I could, if I'm malicious and I would like to tell everybody about what A is doing with my channel, I could do that. But then they would also know what I'm doing today. So I don't know, and you don't gain too much information about payments going over one channel. Okay, I have a small demo. I'm not sure.
Wait, one more question.
Yeah.
One of the big issues with the Tor network is that NSA is expected to hold quite a lot of nodes,
Yeah.
so that they can actually monitor the network.
Yeah.
Do you have any ideas on how to prevent the NSA to just set up all the links that you need to communicate so that they can monitor all the transactions?
Yeah, so this is a valid concern, and they can do the exact same thing here. The only difference is that they have to buy a lot of Bitcoin. They have to buy Bitcoin to set up all these channels everywhere, right?
No, they don't have to buy them. They already
They
impounded
hacked
them.
them, or they...
No, they impounded them from the current
Ah,
criminals.
that's true. Yeah. They use the silver money to open a lot of channels and then monitor the network. So that can happen, but it's yeah. So if NSA has every node on this lab, they would know that A was A because they had all the nodes between them. But if there's one good guy in there, he will save all of them. Okay, more questions? As mentioned, I have a demo. We had a release last night, so maybe everybody on the network is on a newer release than I am. So it might have broken something, but I might be lucky. Yeah, so our Lightning Network daemon is, as I mentioned, a Go client that can be run like everywhere, more or less. Can you see that one? It's probably very small. So this is the daemon running. That was nothing there. And this is my interface to the daemon. I don't know if I have internet. So this is my node running on testnet, of course, not mainnet. I can actually show you the graph because we know about the graph. We can actually print it. So this is the Lightning graph on testnet right now. These nodes probably didn't upgrade their software, so they got kicked out. They exist and they had channels open earlier, but now they don't have any channel. This guy is very popular. This is because this is the faucet. Here you can get free Bitcoin. So, or test Bitcoin, not free Bitcoin. So everybody's connecting to that one to get free Bitcoin on the Lightning Network. And there are already some apps using LND. This is one. If you heard about yours network, they've been working on yours network for many years. This is something one guy created with LND over a weekend. It's basically the same thing. So you have an article, you want to read it, but you have to pay to read it. So you do that. 42, I think it was, how much did they? 42 millisatoshi. Which is as a very, I wouldn't pay more for this article. Okay, so that was all I had. Any more questions before we leave, or I'll be around and answer whatever you want. Yeah.
I was going back to the coffee shop thing again, and you mentioned micropayments. So what kind of infrastructure would need to be in place for actually using micropayments? Because if I'm just going with my wallet into a shop and they have a wallet, the Lightning Network makes no sense. So what kind of stuff would you need to use?
Why doesn't it make sense?
Well, you need two transactions to do one payment.
No, because maybe I already have a channel number. I paid someone before, and I kept that channel open because why close it? I can do that anytime. So I kept that open, and the coffee shop also has a channel open to some other node, random node. And as long as there's a path between us, I can pay them without opening the channel. So that's why.
So is there any downside to keeping that many channels open?
Yeah, there's no downside, of course, because you have to lock your Bitcoin there. So I opened up 10 channels with 0.1 Bitcoin each. I have 1 Bitcoin in the Lightning Network that I can't use outside the Lightning Network without closing all those channels. So that's the downside.
Hypothetically, in the event of a fork, if you have funds locked up in a channel, who gets what?
That's a very good question that has been discussed lately. So as long as the transactions that were created before the fork are valid transactions after the fork, then you get your money on both forks. But as for the Bitcoin Cash fork, they had replay protection that basically makes some transactions not valid on the Bitcoin Cash chain. So then you would need to close your channel before the fork, or you would never be able to close it after the fork. On the hard fork of the chain, on the original chain, you will always have one, of course. Yes.
Is that also true if they both agree they want to close it afterwards? Can they not?
Yes, because that's.
Can't you make a new transaction?
Okay, you're right, yeah. If we agree, we can create a new one with valid format closing transaction. Still, the funding transaction is already in the blockchain, so yeah, you're right. Then if you agree, we can both get the money back. But if we disagree, then maybe not. Okay, I think that's it. And if you have any more questions, just let me know afterwards.